Hello class. Today we're going to be looking at 2.6b, our compositions of functions. But before we do that, I just want to remind us of some of the things that we know about functions. So this is just a look back. If we are given a function f of x, and that equals x squared minus 7, and we're asked to find f of 2, we're going to put 2 in for x every time we see an x. So that's going to be 2 squared minus 7. Well, 2 squared is 4, so 4 minus 7, and we would get negative 3. But we can also put in something with a variable. We could say find f of x minus 1. So we'd have x minus 1 in for the x, and that's going to be squared minus 7. Now x minus 1 squared is the same as x minus 1 times x minus 1, and we'll FOIL that, so we get x squared minus x plus 1, and then we bring down that minus 7. And combining like terms, then we'd have x squared, and that will combine to negative 2x, and this combines to negative 6, and that would be our answer. Now, we're going to be putting compositions of functions together. So let's take a look at what that is. So let's go to our page here of the composition of functions. A composition of functions with f and g, so we have two functions, f and g, is denoted by this little symbol here. And I know we really want to pronounce that fog. It is not. It is said f of g. So that little means of. And it's defined by the equation, so we'd say f of g of x is equal to where we put g of x inside of f of x. And if we're looking for the domain of these, the x is in the domain of g, and in the g of x is in the domain of x. You'll see a little bit as we do these. So let's take a look at what it looks like to do composites. So we're going to be given f of x is equal to 5x plus 6. And we're going to be given, let's just do this color, g of x is 2x squared minus 1. So if I'm doing f of g of x, or we can write that as f of g of x, we're going to take g of x, this one, and put it in to 5x plus 6. So f of g of x we're going to take is going to equal 5, and x is going to be whatever g of x is. So that's 2x squared minus 2x minus 1. And then we still have that plus 6. So we'll distribute this, and we'll have 10x squared minus 10x minus 5 plus 6. And we'll want to put these two combined, like terms together. So we get 10x squared minus 10x plus 1. The domain of f of x is all real numbers. The domain of g of x is all real numbers. So the domain of f of g of x, once again, it's a quadratic, so the domain is all real numbers. Oops, that's a negative infinity to a positive infinity. Now let's do it the other way around, where we're going to put 5x plus 6 in for x every time in the g of x. So g of x is equal to 2 times x squared. So x is replaced with 5x plus 6, and that's going to be squared, minus x, which is 5x plus 6. And then we have this minus 1. So 5x plus 6 squared, remember we're going to do 5x plus 6 times 5x plus 6, and we're going to use FOIL. So we're going to have 2 times, and we do that first. Remember, exponents come before that multiplication. So we're going to have 25x squared That's plus 60x plus 36. And let's distribute this negative. So we have minus 5x minus 6 minus 1. Kind of getting into that other space. Oh no. So I'm going to distribute this 2 now. So I have 50x squared plus 120x plus 72. Oops, that's supposed to be a 2. Minus 5x minus 6 minus 1. Let's combine our like terms. We have 50x squared. We have 120x minus 5x. So that's 115x. Then we have 72 minus 6 minus 1, and that's going to give us 65. Now, if we want to do something without just a number, without a variable, and we want f of 1, g of f of 1, we can put that 1 in for x here, or we could do it at the very beginning. But since I already have g of f of x, I'm going to do it this way. So I am going to take 50 times x, which is 1, squared, plus 115 times x, which is 1, plus 65. So 1 squared is 1, 50 times 1 is 50, 115 times 1 is 115, and then 65. When we add all that together, we get 230. And like I said, we could have done it where we put first into f of x, f of 1 is equal 5 times 1 plus 6, which is 11, and then do g of 11, and you get 2 times 11 squared minus 11 minus 1. So this is 121, so 242 minus 11 minus 1, and that still gives you 230. So either method will work for that. All right, let me see if I can move this paper up a little bit and we can look at the next part of this. So we're going to exclude our values from the domain. Every single one of these had a domain of all real numbers. But what happens when we have to do some exclusions? And that's going to happen when we have exclusions in either the f of x or the g of x or both. So the domain of this one is going to be x cannot equal negative 2. And in this one, x cannot equal 0. So we have both of those domains, but what's the domain of f of g of x? So if I put g of x inside here, I'm going to have 4 over 1 over x plus 2. And I cannot have either of these. Well, I can't have the domain of g, so it can't be 0. And I can't have this be equal to 0. So 1 over x plus 2 cannot equal 0. Or 1 over x cannot equal negative 2. So x cannot equal negative 1/2. And we're also going to include the 0 on that one. The domain of f of g of x. Oh, this is what, I did them all here. This is that part. So we did finish that and I didn't show it to you. I'm so sorry. Let me do that again. So this was the domain, and I'm going to take that denominator, 1 over x plus 2 cannot equal 0. If I subtract 2, I have 1 over x cannot equal negative 2. If I multiply by x on each side, negative 2x cannot equal 1. Divide by negative 2, and we have x cannot equal negative 1/2. And we already had that x cannot equal 0.